So I'm working on making a electronic display for my office that's going to have two rows. One row for NTP based time off my network. But by the way, why is it an NTP clock costs like $200 to $300 on Amazon? Like no one makes one. They're not complex. So Raspberry Pi Pico W, and this is a SPI bus feeding each one of these displays. Um, Little chiclet parts I'll put online, super cheap to buy on Amazon. Thankfully, somebody's made a board for these matrices. I did find that daisy chaining more than what do we got? Like this is four, so three of these. So daisy chaining more than 12 of them together at once was asking for trouble. So it would just get erratic and behave terribly. So you need two separate buses, like one to feed each line of 12, which is fine because you've got plenty of pins on the Pi Pico. So what I've done is I've set up a display for each row. I did feel like the power draw would be a little silly, so I've got it running off my benchtop power supply. And this is brightness 2, so it's 0 to 15 on the brightness settings. And I just want to show you the power. The current we're drawing right now is, see, it's 0.7 amp. So I'm going to change it real quick to, let's change it to full brightness. I'll set it to 15. And fire. There we go. Yeah, so it's ridiculously bright. It's painful to, like, look at my hand. I see it glowing. It's not even good to look at. It just hurts the eyes at that level. But that's 2.3 amp at 5 volt, and I think that's just a ridiculous amount of current for displaying this. So if I switch this back down to 2, which I feel like is a comfortable brightness and not altogether silly, it's almost an amp at 5 volts, and it's actually, you can still see a bit of glow on my hand, which is the best indicator I have for brightness here on the phone. But this is a comfortable brightness where in a well-lit room it's visible, but it's not trying to like scourge your eyeballs. So I think I'm gonna go with that. Anyhow, I'm gonna get some code together, and I'll put all this on a links. Ooh, I've made it mad, and this is what I'm trying to troubleshoot. It does this every now and then, and I've made it mad somehow. I've angered it by putting it on video and talking about it. Let me reset it. Oh, Lord Almighty. Well, let's try resetting this bus here. Come on. Yep. So still troubleshooting apparently. But yeah, not altogether as easy as I would hope. I think I have a bad connection on some solder joints. So there's a solder joint between these four, right? So it'll be coming in on this side. And I might just have a bad solder joint on that. So this is what SPI bus communication issues look like. So that's annoying. I found the issue. It's the jumpers I'm using. They're not good. But doing this made that one mad. Oh, I love SPI bus. This is so fun. Let me tell you how much fun I've been having. Oh my god. Well, let me sort this out. Yeah, so note to self, breadboard pins, not the best for carrying signals above a megahertz. So I did knock the frequency down a bit, and it seems to be quite a bit happier, and some of the pins had kind of started to slip. So anyhow, I'm going to let this set here. It's kind of my burn-in, and I did make a case. So I've made these, and again, I'll probably put this on a GitHub or something. So I've got this little stand I made. You can 3D print for each of the modules from Amazon, whatever Chinese company's making these. Hopefully they're still available. I don't know what's going to happen when they quit making these PCBs. I don't even know what company's making them. Someplace in Shenzhen dumping them on Amazon. But you mount it here, right? It's fantastic. And then you have these underneath as standoffs. And then you have a box that's going to look like this. I made this one too small. This is my prototype, but it's going to be in 2 chunks. So you take the 2 chunks and you join them, and then you're going to have a case that'll hold the display, and you'll put your Pico in there as well. So I've got to redo this in FreeCAD, which is entertaining. I'm not a CAD expert, so I got to go back and alter the dimensions I set all this with, and hopefully the constraints don't completely explode. But I will remake the box that is hollow and then cut it in half with a plane, because that's what you do in FreeCAD. All right, so here's the functional code. It's doing an NTP sync and to my NTP server. So what it does is it'll draw the time with seconds for a bit, and it's going through a loop each second to redraw, and then it shows the date, and it's about 5 seconds, and I'll hop back over and show the time. And I have it in freedom units, so it's month, day, year, not you crazy Euro people. Anyhow, so there you go. So now I've got the Greenwich Mean Time and Central Standard Time. You know, the most important American time is the Central Time, because the coasts aren't as cool. Someone from the coast is going to get salty about that. But anyhow, so yeah, there you go. But yeah, this total current draw for this right now, I'm showing about half an amp at 5 volts. So it will not be running from the Raspberry Pi. I'm going to have an external 5-volt power supply for this whole shindig. That's not a surprise, though. So anyhow, let's get this thing in a case. I have one printing right now in the bamboo. And when it's done, we'll come to it. We'll get this stuff mounted up. I'm reprinting these. I did make these with screw holes in them in the event someone wants to use some other mounting solution. So I've got 2 centered screw holes in each of these for the new model I'll upload. I don't want to force people to use the case I've designed. Like, it's sort of just me throwing it together. But if you want to have these little standoff mounts for these boards, then I figure I'll make it easy. I will make the prints and the files and everything available so people can modify as needed. Hopefully this turns into a little fun project others can play with, and they don't have to spend stupid like $400 on an LED display. By the way, schools are getting scammed by this. I know it's like a lot of this sells to institutions or schools, and they're charging like $600 for a display that does multiple time zones, which is just dumb. I think altogether in this project, I paid like what was it? 20? No, it wasn't even 20. Like 15 for the Pi, and like one of these boards. I don't know. It's just cheap. Like, I didn't pay $100 for this. I have to add together the full bomb now, because I don't even remember what I paid for this. It was so cheap. It wasn't $400. I'll damn near tell you that. So, all right. We'll be back. All right, it's been quite a bit of work. Let me restart this real quick so I can go from the beginning. So now you'll see, and it's upside down because I'm working on it, obviously, but you'll see temperature and power and my Geiger counter and all kinds of stuff. So I'll talk about it as we go. Right now, this is a clock, so it's cooked by NTP server. There's date, again, from the NTP server. So I've got Greenwich Mean and I've got my Central Standard. This is my Geiger counter display. So pulling data from my rack-mounted Geiger counter. You see it's updating. It's pulling from zabbix. So it's doing API queries to zabbix as it's displaying it every second, because it's my server. I don't care if I hammer it. This is hitting my HomeAssistant server. Wattage on panel A and panel B. I've got 2 panels here at the house. So you see that's updating every second as well. We're just sitting here pulling it as we're displaying it. So this is live display of wattage. So let this set for 5 seconds, and then this is to 15. I have to go back to that. Okay. This is wind speed. So this is pulling zabbix again. I could pull this from HomeAssistant, but everything combed in there. So then this is temperature and barometric pressure. So inches of mercury, freedom units. Inches and inches an hour precipitation. And again, this is all pulling zabbix because I've got the data in there, and we're back to the clock. So basically I've got time, time radioactivity. Not that I have any, but I thought it was pretty cool to have the Geiger counter in here. And then all the temperature stuff and weather display, as well as panel wattage. I could also include wattage and temperature for the server room in here, but this will all be, I'll release the source for all of this. So if you've got zabbix or if you have HomeAssistant, you can pull data from either one. And it's really, I've got everything set up as functions, so you can just sort of like structure your query and then tell it to like, hey, display this, run the query and display it. It's not hard, and it just sits there and loops it. So it's really easy. And having to deal with FreeCAD, I honestly think dealing with FreeCAD was worse than dealing with the code. I'd rather deal with the code on this any day than deal with FreeCAD. I'm not a CAD guy. It's not terrible, but it's also not my favorite. I have way more fun in this because I can make a code change and push go, and I'm hooked into USB right now, and then my changes instantly go through. This is my first time using Raspberry Pi Picos. I was amazed at how easy it was to work with this versus the Arduinos I'm used to using, because I suck at writing C, but Python is like stupid easy, and you could be an idiot and write Python. So I mean, here I am. All right, carrying on. Well, I found a new use for this this tool from Covert Instruments. Works great for pulling out LED modules. So, in addition to a lockpicking set, really good for getting in there between I was able to get between an element here and kind of get the corner and pull up, as well as using this tension tool to pull up from the other side. So yeah, it worked. I was able to get single module out without having to be super crazy. I would not recommend building it this way. I think I'll publish it with these drawings, but if you have to do any sort of maintenance, I'm sorry. It's going to suck. So Sony probably to take this solid print and redesign it. Anyhow, I mean, it works. So at least the code is functional. I told you I hate FreeCAD. All right.
All right. So it's in a box now. Still playing with programming, so I have USB hooked up. The USB is not completely necessary. The whole thing will run off of external power when you have this pin hooked up. You don't power it by the pin and USB at the same time. However, I digress. So this is looking at my Home Assistant panel monitors from Empora Energy. So it's hitting the Prometheus scrape page for Home Assistant. So even if you just have Home Assistant and you don't have a Prometheus server, you can use this code. And you see it's updating. So once a second, as it's displaying this, it's pulling the scrape page and just displaying the metrics you've selected. Took some interesting stuff because it's very limited memory, and it didn't want to, like, obviously ingest the whole thing and then process it. So I had to do you'll see the source. So pretty cool, though. It'll sit there and scrape once a second and display whatever metrics you want. It doesn't have to be panel wattage, right? Anything in Home Assistant. And then I've got, this is coming from zabbix, so this is going to also update once a second. There is outdoor temperature and barometric pressure. Again, the zabbix items, that could be CPU, memory, whatever you want. This is rain. Also, again, I'm using zabbix. And then there's my time. So I've got AM and PM working properly. You can see it's 7 o'clock Central Time, and that's 12 o'clock AM GMT. So you can see that I have PM and AM properly calculating for 12-hour time now. And getting DST and all that programmed in was frustrating. And then I've got dates. So Greenwich Mean Time on bottom and my local time on top. And then again, I'm going to radiation for my Geiger counter in the rack. I got a video on that. That's 7 counts per minute. And, 0.3 microsieverts, 0.03 microsieverts. Because why not? I don't live in an area with radiation. But it's really cool to have, right? Who knows? If the bomb goes off and we're in a fallout scenario, I'll be the guy with a Geiger counter on the wall. All right. These little chiplets, you can buy these little chiclet boards. They're on Amazon. The ones I keep finding are generally 4 module, but I found a couple that are 8 now. This code is set up to run on a 12 wide matrix, so it's 12 of these 8x8 cells. It's these little guys, so 12 of these per each row. You could get by dropping off the last 4, omitting the last 4 on this panel, but you can see how much you'd have to delete a lot of spaces in the strings. You'd have to, on the time display, you'd have to drop the time zone and AM, PM. If you look, I use the whole thing for time. You could also omit this, but I think it would be very hard to read. So to have the full time plus time zone and AM, PM, it takes 12. That's up to you. If you're going to do 24-hour time, you can omit 1. If you want to get rid of time zone, you can now, omit 4. So that was why it's 12 wide. Anyhow, I hope that this inspires people to build some stuff. I made this box way bigger. I initially had it super small. And I decided I wanted a ton of space down here, so I could maybe put a buzzer in based on an alarm clock, or I could have a sounder, or maybe a flash, or I just wanted to have an option for having more stuff. So there's a lot more space in this case now. I printed it. It's split right down the middle. It's just hot snotted. I mean, it's plenty strong. But I've hot glued everything in there. You got enough room to get your hands in and pull the modules out, so I can get my fingers in here, and I can also pull stuff out pretty easily. I think I've got video of how hard it was to pull the modules out in the small case I built, and I just decided I'm never doing that again. And I got to find some kind of cover for it. Either way, work in progress. This is probably good enough for me, but someone else out there with Fusion 360 or something will go design some really pretty case for this. The code is typical dog snot code, for me, but it's it's usable. So I'm going to give it to you guys, and you can use it and have it for free. And I hope it helps someone. And I hope you have a zabbix thing you want to monitor. You could have your gaming PC temperature. You could have your video card temperature and CPU on there. I don't play enough games to care, but you could do that. All right. And if you can't find this on your link that I give you, look for a Max 7219, and you'll just find tons of these things for Max 7219 display. You'll find a bunch of these. You'll find singles you can buy. You'll find quads. You'll find by 8. So there's a bunch of Chinese suppliers selling these on Amazon for cheap. Buy them. It's pre-made PCBs. Maybe somebody out there will sell like on Tindy an affordable one, but so far the Chinese ones on Amazon are really good. Strapping them together, I should mention as well, was annoying. So on the back, if you look right here, let me get my focus to work. My apologies, I'm cell phoning here. Ooh, there we go. So where those pins are in the very back, come on. Oh, cell phone. There you go. See the pins? This is where you have to solder them together. So data out will go to data in on the other side, which would be, whoop, there you go. So I was using aluminum wire, and that worked pretty well until it didn't. So I initially tried using nichrome, and I didn't know this. Solder doesn't stick to nichrome, so that was bad. Aluminum worked better, but I think that what ended up being my favorite was I ended up giving up and just using some Kynar wire I had, which seems like overkill, and I was doing the joints with Kynar. But if you've got just like some general hookup wire and you feel like cutting little tiny sections and making bridges, that'll work. I just don't know if people have like you basically need a bridge clip of some sort. So tie the boards together in some way that's stable, and then I will tell you for troubleshooting, as you saw on my display, loose connections cause it to go like solid colors to not connect. If the connections are really bad, it'll cause both panels to not work and do crazy things. The one thing I would say is I decreased the frequency. The default frequency for this driver for the Raspberry Pi Pico is way too fast. You don't need 10 megahertz. I mean, I'm not running a frame buffer trying to draw video, low resolution video on this, right? I'm just trying to display text. So I think I've got this set at a couple kilohertz. Like it doesn't need to be that fast. SpyBus can go super slow for this, and it makes it a bit more resilient. 5-volt power supply does need to be somewhat decent for this. If it's got a lot of ripple in it, it's going to do weird stuff. You can add a filter cap on the power. So like between your positive and negative leads here, you could just add a relatively large size capacitor electrolytic, and I've tried that and intentionally used a dirty power supply, and it ran for a couple days with no problem. So if you do have a dirty power supply and you're having issues, tie an electrolytic cap between the power feeds going on the board. I think when it switches to the clock and it pulls that much current, or you go to anything, it's got a lot of letters just lighting up. I have the display brightness set to 2 as well. Something else to mention. At a display brightness of 2, my peak current is about 300 milliamp. But if I switch to like full power, it'll be up to 2 amps. Like if I make everything lit. So you're gonna need to like match your power supply intelligently. Like don't download this code and put this on a 500 milliamp power supply, then turn it to like whatever. I was at 12. It goes up to 16, so it's a 15 because it starts at 0. So don't put it at 15 brightness and like plug in a cheap power supply because you're gonna melt it. It will draw some power, and I don't know if it's cooled enough for that. It's been running for a couple days, and it's not warm on the top, but you can feel a little bit of warmth from the board. It doesn't get hot, but it's definitely not room temp. Anyhow, my rambling aside, I hope you enjoy this.